In this example, I'd like to solve the quadratic equation 3x squared equals 8x minus 10. So here again, the first order of business is to get a 0 on one side. Because I have this x to the first term, I know I don't have just a square term and a constant, so I can't solve with the square root property. If I'm going to use either factoring or solving with the quadratic formula, either of those methods depends on having a 0 on one side of the equation. So I'm going to move everything to the side that the squared term lies on, because these are just typically easier to deal with if your squared term is positive. So I'm going to do minus 8x plus 10 to both sides of this equation so that everything cancels on the right side. So on the right side of this equation, I just have 0. On the left side, I have 3x squared minus 8x plus 10. Okay, if I was going to try to factor this, I would need to find two numbers whose product is a times c, which in this case is 3 times 10, so 30, and whose sum is b in the middle here, which is negative 8. And if you go through your options, okay, so how can I factor 30? What are numbers that multiply to give me 30? So that's 1 times 30. Okay, I'm not going to get 8 out of that. 2 times 15. 3 times 10. Not 4. 5 times 6. And that's kind of it, right? But so none of those, I can't combine any of those pairs of numbers and get negative 8. So factoring is not going to work. So plan B then is the quadratic formula. So if we solve using the quadratic formula, you're going to need to know what your values of a, b, and c are. And that's referring back to the standard form of a quadratic equation, which is ax squared plus bx plus c equals 0. So comparing that general form with what we have here, we see that a is 3, b is the coefficient of x, so it's negative 8, and c is 10. Plug that into the quadratic formula, which says x is equal to opposite of b, so that'll be positive 8, plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Okay, so that's plugging into the quadratic formula. That gives me, let's see, what do we get under the radical? Let's focus on this right here. So under the radical, you have negative 8 squared, so that's positive 64, minus 4 times 3 is 12, times 10 is 120. So we're going to have a negative number here. Let's see, difference between 64 and 120 is 56, but it's a smaller number minus the bigger number, so this is negative 56. So we have 8 plus or minus the square root of negative 56 when we did the arithmetic for what's under the radical here. All divided by 2 times 3, which is 6. Let's see, can we simplify that radical expression? I'm going to do scratch work off to the side again for that. So the square root of negative 56. First of all, it's a square root of a negative, so I can write that as I times the square root of positive 56. 4 does divide into 56, right? Because 40 would be 4 times 10, and then you've got another 16. So that's 4 times 4. So 56 is 4 times 14. And we could take the square root of 4, that's 2. Now with 14, so that factors as 7 times 2, which 7 and 2 are both prime. Neither of those factors is a perfect square. So there are no more perfect square factors that I can divide out of this 14 here. So this is the simplified form for this radical expression right here. So this is equal to 8 plus or minus, instead of the square root of negative 56, we'll write this as 2I square root of 14, all divided by 6. Now if we want to write that in the standard form, we should separate this out. Separate your real part here and your imaginary part here. So I can simplify this first fraction by dividing the top and the bottom by 2. If I divide 8 divided by 2, that's 4. 6 divided by 2, that's 3. So the 8/6 reduces to, here, I'm dividing the top and bottom by 2. And that reduces it to 4/3. Here also we can divide the top and bottom by 2. When you divide by 2 in the numerator here, that's going to cancel the 2 in front. So you'll have just let's see, I can't forget the plus or minus. I square root of 14. 6 divided by 2 is 3, so over 3. So there's the standard form for our solutions to this equation.